by the end of today's video, I will prove you wrong.
If you go straight to a computer and shout at it to do something, will you do? Now, your Japan friend only knows Japanese and you only know English.
Getting a complete overview of Java, programming isn't about typing. Let me ask you a simple question. Do you think programming is difficult? If your answer is yes, good. Because by the end of today's video, I will prove you wrong. Most people don't find programming difficult because they are not smart. They find it difficult because nobody explained to me in such a way that it actually makes sense. Today, we will change that. Hi, I'm Veera, working as a software engineer at Google as an external workforce. Welcome to Veera Builds. Today, we are learning the absolute fundamentals of programming and getting a complete overview of Java. By the end of today's video, you will get to know what programming actually is, why it exists, and why Java is used to build applications. So, let's get started. When I started learning programming, I was completely terrified. I looked at the screen for hours and thinking, can I even do this? But then I have realized something that changed everything. Programming isn't about typing. Programming isn't about memorizing syntax. Programming is about problem solving. The coding part comes much later. For your better understanding, let me give you an example first. Imagine this real life scenario. For example, if your grandmother health is not good and she asked you to remind her to take medicine every single night at sharply 8 p.m. Now you have a problem to solve. Let me know how do you solve it. One way is to do it manually. Every single night you have to look at the clock and wait for 8 p.m. When the time hits 8, drop whatever you are doing and you just have to go and remind her. But what if you are sleeping at that time? Or you are out with some friends, or in the worst case scenario, as a human, you might forget it as well, right?
Now, instead of doing it manually, you decided to solve it by using code. Now you open your laptop and built a small application in which you wrote these kind of instructions clearly. What? Check the time. When the time is 8 p.m. sharply, just trigger an alarm. When the alarm triggers, you should also display a message which says that, Grandma, now the time is 8 p.m. You have to take your medicine. So please go and take. So what did you do here? You took a real world problem, broke down into small and clear steps. Now you came up with a solution and automated it. This is exactly what called programming is. Beauty, right? So if programming is just taking a problem and breaking down into steps, why do we need computers? Because humans get tired and they forget. Let me ask you a simple question. If I ask you to calculate the attendance for 5 students, you can do it in split seconds, right? But what if I ask you to calculate the attendance of 50,000 students every single day, that too without an error? Your brain will melt, right? So that is why computers are there. Computers are incredibly fast. They can do billions of operations in just a heartbeat. But they will do exactly what we tell them to do because they don't have their own brain. Now you got to know that computers don't have their own brain and they will exactly do what we tell them to do. If that's the case, if you go straight to a computer and shout at it to do something, will you do? Of course no, right? Why? Because it won't understand your language. If that's the case, in what language can computers understand? Just take a guess. Now some people might say it's English or some people might guess it's Java, but the answer is neither of them. A computer was just a piece of hardware that was powered by electricity. It can understand only two states, which are on and off. In computer science, these were represented by 1 and 0. The language of these ones and zeros is exactly called as binary. This video what you are watching now, the food what you have ordered yesterday, and the Instagram post you have made last month, and the reels what you are watching daily are just a billions of zeros and ones moving at lightning speed. But humans cannot write code in zeros and ones, right? Imagine trying to write an entire application using just zeros and ones. You would be crazy. So for that reason we have created the language called Java. But wait, there is a problem. We have created a programming language like Java, but computers only understand binary, which is zeros and ones. There is a gap, right? How can we bridge it? To understand this, we need a solid example. Chalo. Imagine there is a friend of you living in Japan and you want to write a letter to them saying just a hi. Now, your Japan friend only knows Japanese and you only know English. Now, is the communication possible here? Absolutely not, right? So clever you appointed a common friend as a translator. Now, this common friend can translate your love letter, letter into Japanese so that your hi message can be translated as konnichiwa so that the Japanese girl will get to know that you have said hi. Did you observe something? You just learned how to say hi in Japanese. Thank me later. In this same exact way, a brilliant piece of software in your computer acts as a translator. This is called as Java Virtual Machine. Simply we can call it as JVM. This takes the Java code and converts into binary. But we cannot trust our friends in these kind of situations, I guess. Why? Because what if our friend intentionally or mistakenly translates our sweet hi message into a blunt bye? Our whole conversation will be ruined, right? Why? Because humans can make mistakes. But that's not the case with the JVM. Our JVM is completely loyal and incredibly stable. So whatever the code you have written in Java, that will be as it is translated into binary without any change. Nothing more, nothing less. Because of this brilliant JVM setup, Java got a superpower called WORA, which means that write once, run anywhere. Example, if you have written a Java program on a Windows laptop, you can run the same Java program on Mac or Linux independent of platform and without even changing a single line of code. That is what called WORA. Write once, run anywhere. This is the superpower for Java. Remember this and later don't say that I never taught you this. Okay. Now, these are the reasons why Java is trusted by many big companies like Netflix, Uber, Spotify, and global banks, and countless enterprise level applications. Because Java is so massive, many beginners often fall into this trap, arguing on Reddit and social media platforms that Java is better than Python or Python is better than Java. And most people will think about what is the best first language to learn. Please don't do that. And many more beginners try to remember the definitions for JVM, JRE, JDK, bytecode, compiler, and all those things. To be honest, you don't need all those definitions right now. When the time comes, I will be for sure teaching you all these things. So don't need to worry. Time for a quick recap. What is the first point says? Programming is not about typing the code, but it is the ability to solve problems step by step. Now the second point says computers don't think like humans. They will exactly implement what we tell them to do. And now the third point, computers understand only binary, means at the hardware level they will work with only zeros and ones. Now the fourth point, the JVM helps run Java programs. For now, think it as a smart assistant that prepares your Java program to run on your computer. And now comes to the Java's biggest advantage, which is WORA, which means write once, run anywhere, which I have already discussed earlier. You can run the same Java program on any operating system with little or no change at all. Got it? Now, the biggest takeaway. Strong programming logic is far more important than memorizing syntax or arguing about other programming languages. Got it? Congrats! We just completed our module 0. Today, you didn't learn Java, but you have learned something more important than that. That is, you have learned how programmers think. And trust me, this mindset is going to be helpful throughout this journey. One concept at a time, one step at a time. That is how great programmers are built. Every tech lead, every senior engineer, and every tech founder once sat exactly where you are sitting right now and wondering how to start. But you don't have to stress about anything what to learn next, because I have personally created this roadmap which contains level 0 foundation, level 1 logic building 50, and mini projects, DSA, OOPS, and job ready interview preparation as well. The best thing about this roadmap is it was completely formulated so that you can track your progress anytime. Now, I'm providing the link in the description below, so go and get the sheet. Once you get the sheet, click on this file and make a copy so that locally you can prepare your own copy. And here is my promise. Stick to this roadmap with discipline, and I will take you from zero to a solid Java plus DSA problem solver who can confidently tackle any interview in any company. And that's it for today's, guys, and I will see you in the next one.